Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, Official Guide to the Revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 233. Please turn to it. Page number 233. Today is our lesson number 328. The problem there that you see, problem number 8 on page number 233, is the exact same problem that appeared in the first edition of the revised GRE. We have already solved every single problem from this book. If you're interested in watching the original solution, you will find the original solution to the problem on day number 115. Now, what we did yesterday and what we're going to do today, I want to talk about the difference a little bit before we actually get going. Yesterday, on day number 327, we did the problem that you see on the previous page, 2.7.7, problem number 7. That problem was a little different. That problem was more of a traditional problem, more of an orthodox problem, more of a classical problem, where we are typically asked, if I invest a certain amount of money today, how much will I have at the end of the period, however long the period happens to be. So in that problem, in yesterday's problem, the question was, what is the amount of interest that we're going to earn on $1,000 investment that we're going to make today if it pays 6% and it's going to be compounded annually for 3 years. And what we found yesterday is that we earned $191. We earned $191 in interest. Another way of asking the same question would have been, what is the total amount of money we will have in the account at the end of the 3 years? At the end of the 3 years, if we were to invest $1,000 today, and if the investment were to pay 6% compounded annually, to which the answer would have been $1,191. $1,000 that we started out with, our initial investment, and $191 in interest. In other words, at the end of 3 years, our account would have a balance of $1,191. Now that is more of a traditional setup. In this question, it's the topsy-turvy world. Here, it is on its head. Here, we are not asking how much money we will have at the end of a given period, but the question here is, what do we need to invest today? What must we invest today? What do we need to invest today in order for us to have, at the end of 3 years, $1,000 in the account? What do we need to invest today in order for us to have $1,000 in our account at the end of 3 years if the investment is going to pay 3.5% interest that is going to be compounded annually? So let's see what we can do here. So that's the unknown here. The unknown here is not the amount of interest we're going to earn. The unknown here is, what do I need to invest today? Let's find out, shall we? So that's our unknown here. Let's give that unknown variable a name so that we can talk about it, so that we can maneuver it and handle it. Okay? Let's call that unknown. Let's pretend the amount of investment is $P. Traditionally, we use letter P for the unknown quantity that you start out with, which represents the principal. So what principal do I need to begin my story with, so that at the end of 3 years rather, we will have exactly $1,000 in our account if it were to pay 3.5% interest, which is going to be compounded annually for a period of 3 years. Let's find out. So what's going to happen at the end of first year? If we start out with this amount, P dollars, P for principal, at the end of the first year, our P dollar will increase to what? Well, we'll have $P that we started out with plus 3.5% of it, plus 3.5% of P. Of course, 3.5%, we have to write it in decimal form. For example, 10%, we write it as 0.1, 50% we're going to write it as 0.5, 25% is going to be written as 0.25. We have to write it in decimal form. So this is going to be same as 3.5% is to be written as 0.035 times P. Keep watching, okay? Pay attention. Now see, here is our first term, here is our second term. This is our second term right here. This is our first term. What factors do we find common in the two terms? The common factor is P. Common factor is P. Let's take the P common out. Let's take out P common. If we take out the P common, what are we left with this term here? In the first term here, we had a P here. If we take out P common, we are left with 1. Because 1 times P is going to give us our P. Plus, here we had 0.035 times P. If we take out P as a common factor, we are left with 0.035 P. Again, you see, P times 0.035, P times 0.035 is what we have here, 0.035 times P. That's the amount we're going to have at the end of the first year. Now the story for the second year is going to begin with this amount. Our story for the second year will have the starting point of that amount, P times 0.035. That's it, P times 0.035, not P. P is already taken out. That's what am I doing? That's it. This is our beginning story. Let's continue. Our balance at the end of the second year will be, so this is the balance we'll have at the end of the first year. End of the first year. This is the amount we're going to have in the account at the end of the first year. Let's find out how much money we will have at the end of the second year. Once we figure out how much money we have at the end of the second year, we just need to go one more step and find out the amount we will have at the end of the third year. And once we find out how much money we will have at the end of the third year, expressed in terms of P, all we have to do is equate that amount to the money that we actually want, which is $1,000 at the end of 3 years, and just solve for P. That's all. I need the room, obviously. Let's do it over here. At the end of the second year, we will earn 3.5% on this amount right here, P times 1.035. This is how much we will earn. Okay, as I said, pay attention so that once you understand the derivation of the formula, you will no longer have to memorize it. Because we will understand the concept behind it. It's a very simple, very straightforward concept, and therefore knowing the formula is going to be that much easier. You won't have to remember the formula at all because it will become intuitive, it will become logical. So that's it. This is the amount we will earn at the end of the second year. But that's not the total amount of money we will have at the end of the second year, because this is the amount of interest we will earn on it, and this is the amount we start out with. So our total money, our balance at the end of the second year will be this amount that we start out with, which is P times 1.035. This amount that we start out with, this is the amount that we start out our second year with, plus 3.5% of that amount. So it's P times 1.035 plus 3.5%. Of P times 1.035. Again, 3.5% has to be written in the decimal form, so that's what we'll do. P times 1.035 plus 0.035 times P times 1.035. Okay, are you with me so far still? Very good job. Now here's our first term, and here is our second term. Do you find any common factor in those two terms? The common factors in those two terms are, and I'm just going to underline the common factors now. I'm going to erase this part now. This is our first term, this is our second term, and the common factors in the two terms are this part right here. This right here, p times 1.05 appears in this term, and p times 1.05 appears in that term. Let's take it out common, shall we? P times 1.035 is taken out. Once we take out the term common, what are we left with in the first term? What are we left with in the first term here? We're left with nothing. Well, how do we write nothing? Well, nothing is not to be written written as 0. What we mean is that we are just left with 1. Nothing else. Because p times 1.035 times 1 is going to give us this amount that we started out with. p times 1.035 times 1 is going to give us p times 1.035. What are we left with in the second term? In the second term, we took out this part common. That is the common factor, we took it out. So we're left with this portion here, 1.035. Not 1.035 rather. Which of course can be written as, I don't want to keep going down and down, it's getting too low. So I'm going to start from the top now. So this part we'll pick up from here. P times 1.035 times 1 plus 0.035 is what we have, which of course can be written as 1.035 times 1.035, which of course can be written as 1.035 times 1.035 is just 1.035 squared. This is the amount we will have at the end of the second year. The second year that you see there is our exponent right here. That exponent tells us how many years have gone by. Finding the amount that we will have at the end of the third year is very simple. Instead of a power of second, we'll have a power of third. That's it. That's it. We're done. Let's continue. Our balance at the end of the third year, at the end of the third year, our initial investment of $P will have balloon to how much? We just talked about it. Since we're talking about third year, it's this right here. P times 1.035 raised to not the second power. Second power represents the amount we have at the end of the second year, which was a continuation from here. At the end of the third year, we'll have this much amount. That's the amount we'll have in the account at the end of the third year. So however many years we have, and now when I say years, that's actually misleading. It's not years actually, it is periods. Listen very carefully. It is not this here. So the general formula is this. P times 1.035 raised to n. N here represents the number of periods. Now listen very carefully. As I said, I kept calling it years so far, and now I'm going to switch the terminology. We're going to start using terminology which is more proper, which is more general. N here represents the number of periods. It's not the number of years. The reason why I kept calling it number of years, because in our case, it doesn't matter whether we call it years or periods, because our period is a period of 1 year. because we were compounding annually. Had we been dealing with the situations where it was compounded semi-annually, then a period of 3 years, I shouldn't use the word period in that sentence, then a duration of 3 years would have resulted in 6 periods, because each period would have been 6 months long, in which case our n would have been 6. So n here does not represent how many years there were in the problem, but rather how many periods there were. Let's do one more time, shall we? If we were given a situations where the interest that we were earning on the account was compounded monthly, then in a duration of 3 years, you see how I avoided the period of 3 years? Because the word period has a special meaning in our conversation. Then a duration of 3 years would have had a period, or would have had 36 periods, because 36 months make a duration of 3 years. So here, one more time, n represents the number of periods. It could be anything. You can compound monthly, we can compound annually, we can compound semi-annually, we can compound quarterly. Had we been compounding quarterly, then each year has 4 quarters. A duration of 3 years would have had 12 quarters, in which case our n would have been 12 periods. But you get the idea. This part that you see there, 0.035, is our interest, 3.5%. Instead of 3.5%, so it's 1 plus 0.035. Instead of 3.5%, in the general term, we write that as 1 plus r. R here represents the rate of interest. Rate of interest per period. Listen very carefully. It is not rate of interest, it is not an annual rate of interest, it is rate of interest per period. Again, reason why in our conversation it did not matter, because we are dealing with a very simple scenario. We are compounding annually. Therefore, the rate of interest per period is same as the annual rate of return. You follow me? In other words, listen one more time, I'm going to say slowly. In other words, if we had an investment which paid 6% return, and if it was compounded semi-annually, then the rate of interest per period would not have been 6%. The rate of interest per period in that case would be 3%, because it is 6% per year and is compounded semi-annually, so half of 6 is 3. If you have an investment that pays 12% rate of return, and it is of such a nature that the interest is compounded monthly, then the monthly interest rate is only 1%, because 1 times 12 is 12% per year. But the interest rates are always stated on a per annum basis, per year basis. When the problem says it pays you 12% interest, it is understood that it is 12% per year. Now it is up to you to be smart enough to ask yourself, does that 12% apply in the problem, or do I need to adjust it based on how many periods we have in the year? Well, if it's compounded annually, then the distinction between the period and a year ceases to exist, because one period is 1 year. You get the idea. Anyway, so this is our general formula here, P times 1 plus R raised to N. So that's the amount of money that we will have in the account at the end of 3 years. We are done. We want this amount to be equal to $1,000. We want this amount to be equal to $1,000. That's it. All we have to do now is solve this equation for P. We are done. Divide both sides by this amount, we will have a P by itself. Let's do it here. I don't want to erase this part here. Let's do it over here. So this equation implies that the P that we're trying to solve for is $1,000 that we want in the account at the end of the period. When I say end of the period, I'm using the word period now in the sense of a simple English language. You understand? At the end of our investment, at the end of the duration of our investment, which was 3 years. We have to be careful with the jargon, you see. Here we're using period as a terminology. So we divide both sides by this amount, 1.035 raised to 3. 1.035 raised to 3. That's it. That's it, we are done. Once we get to that stage, Now listen very carefully, as I keep telling you, once we get to that stage, this is where the difference between the old GRE and the new GRE comes into play. In the old GRE that existed up until a few years ago, 2-3 years ago, the calculators were not allowed. Calculators were not allowed, and in the old GRE, they would never give you a problem of this nature. Because the only way we can actually solve this amount is through a calculator. If you try to do this manually, it will take us forever and ever and ever. It will take too much amount of time. It will take inordinate amount of time. It will take inordinate amount of time. It will take excessive amount of time. It will take unreasonable amount of time to try to solve this thing manually. Calculator is our only hope. Now, having said that, that does not mean that you reach for the bloody thing every 5 seconds. Use it sparsely, though. Use it when it is absolutely necessary. In the entire course of the exam, you should not have to reach for the calculator more than maybe half a dozen times. That's it. This is one of those times. Reach your calculator, find out how much is. So divide 1000 by 1.035. Once we have the result, divide that amount again by 1.035. Once you have the result, divide that amount again by 1.035. In other words, we need to divide 1000 by 1.035 3 times in a row, and if you do that, you will find that it comes out to be approximately $902. But to go from here to here, the only way we can go through from here to here is with the calculator. There is no other way. Or at least if there is, I can't think of any. But anyway, that was the end of our journey. This is the concept of compound interest, the formula behind it, and this is what we need to use. This is exactly what we were going to have to use in the next problem that we're looking at, which is 2.7.9, which is even more kinky. Do you understand? Yes, things are going to get kinky. I know that. Yes, I know you were not prepared for it, but you have to be kinky in order for you to do the problems that we encounter on the GRE, the hard ones. We'll do this next one, as I said, which is going to get quite kinky tomorrow. Okay? Bye now.